All right, good afternoon, guys. My name is Eugene Conner, dev here at cars.com. I'm going to present a little bit on DynamoDB today. And I fully realize database presentation, high carb lunch, it's a combination for some sleepiness, but hopefully I'm just going to keep it to some, just like the most interesting paradigms DynamoDB offers. We'll dive into a little code. We'll talk about how it stacks up against some of the competitors, and hopefully you appreciate it by the end of this. So Dynamo, if you don't know, is Amazon's NoSQL state store. It's what they use for their shopping cart. It's what they use to handle hundreds of thousands of concurrent shopping cart instances. During the holidays, it goes into the millions probably. And I've never seen a mistake on Amazon, at least in my shopping cart. I did have the wrong vinyl sent to me many, many times, but that's a whole different story. All I wanted was Alice Coltrane. They kept sending me Swedish metal, so that was cool. We got it resolved though. Not a Dynamo issue, not a Dynamo related issue, I don't think so. But before I start, I'll just kick a little scenario here and pick on Lee. So let's rewind the clock back to May 2016. Lee Page is sitting at his desk. He's slinging code, being weird, and he has this sudden epiphany. Big idea, huge idea, so huge he quits on the spot. He runs home and just starts ravenously slinging code, right? So he builds this algorithm, and the idea is he wants to create like a website that crawls all the cool websites that millennials go on, 4chan, Reddit, and finds all the memes that are rising and getting more and more popular. And he creates this algorithm that finds the most dankest, popularest meme, and he brings it in and just slaps it on a bunch of shitty-ass merchandise and puts it in a store. He's slinging shirts, water bottles, pens, anything you can put a meme on. It's a great idea. So he gets it up and running, and he knows he needs a database. He wants a NoSQL state store. He wants it to be free. He doesn't like so much doing DBA, database administration things. He doesn't want to scaffold. He doesn't want to really worry about data architecture. He doesn't really want to worry about reconfiguring it if they need to add new storage nodes. He really doesn't want to implement fault tolerance because he's so lazy. But he will do fault injection if they don't worry. He wants it to be really fast too, sub-millisecond. He needs, memes are constantly changing. They constantly need to be stored and retrieved. So he basically, and once his awesome startup gets funded, he's going to need it to scale for free. So he lands on DynamoDB. He's done a little bit of research. He decides to go with me. And I just basically detailed all those things. So he's going along. He's a couple weeks in. Nothing's really popping. This is early May, mid-May now, 2016. So nothing's really going on the interwebs. Then May 28th, the day after my birthday, comes along. And a young boy in Cincinnati wakes up and is so excited because they're going to the zoo that day. And that day, we will never forget. And Lee was ready. Lee's website was ready. He just smashed it. Harambe was on everything. And Lee was banking. And he was able to handle this viral burst too. It's crazy. So how did Lee make all this money? Why was his database just like, he hates configuring. Why was it so successful? Okay. So this takes us into some of the main goods, the main paradigms that makes DynamoDB a little bit separate from the rest. Thank you, Harambe. So first of all, it's always writable. And I'm going to touch on these and then really go into them in a little more in depth in subsequent slides, so don't worry. It's always writable, and it's almost ACID compliant. What is ACID? Well, it's an acronym, first of all. But going from the back, we got durable, isolated, consistent, and atomic. Atomic means either this request is going to be fulfilled completely to the end, and these are traits that a database should have. Either that request is going to go all the way, or it's going to die completely. There's no half-ass, there's no half-step-in, there's no partial updates, no partial reads. Durable, if your database is burning down, are you still returning correct responses? Isolated, that has to do with concurrency. If you are making updates, is your system going to give the same responses as if it was a synchronous system as it was asynchronous? So if you have all kinds of processes running at once, how isolated is it? Is it giving the same exact response that it would if you were just doing one request at a time more safely? And then the C is the key here. It's what Dynamo kind of hinges on. They trade away a little bit of the consistency. And consistency is is your database updated at all nodes in the same way? Is the same update being made with the same data in the same style every time? I don't know. So we move on. Consistent hashing here is what they basically use for partitioning, and as the data flows in and out, how do we regulate it, and how do we make it fast? Eventually, consistent has to do with that trade-off in the C, in ACID. So, you know, a regular database might advertise that it's strongly consistent. Well, this has to do with, in Dynamo, they replicate data across many nodes. As it comes in, the request returns back to the client, and while, even after it's been returned most of the time, it's being replicated in other nodes. And you run into some issues that we'll talk about with that there. So out of the box, Dynamo's eventually ACID compliant. Like I said, it favors availability over consistency. So no matter what, they're going to let you write, and no matter what, they're going to return on a get. No matter what. The get might be a little suspect if there's been some issues, but the write is always going to go. So with that, though, and you might say that's a bad thing, but you can completely customize all the trade-offs. They give you read and write capacity units. You can play with them as see fit within your app, and you can make up for that trade-off in availability if you want to. And then for Harambe traffic influxes, you have burst capacity. They give you about 300 seconds or 5 minutes of processing time extra in case you need it, which is nice. So this always writable thing. So database writes in Dynamo, they will never fail. There's nothing you can do. They're like Superman. Sorry. You can't stop. It doesn't matter. Not now, not ever. So why did they do this? Why did they make DynamoDB always writable? Well, if you think about Amazon's business logic, it would be a pretty crappy experience if you were on there and let's say Keith's on there and he's buying Indians jerseys and he adds a Lindor jersey and he goes and to his shopping cart to check out because that's all he needs, and it's gone. It's not there. He's like, what the hell? What a terrible experience. So Amazon considered that, because if that happened to you, you'd probably bounce off the website. You would probably be like, all right, let me just get this Indians jersey somewhere else. There's plenty of other stores that sell it. This is like already a suspect experience, and that's lost revenue. So they were not trying to have that whatsoever. A second point of this is that writes will not do any version conflict. So they'll always be written in, and they will not like worry about if there's a similar write that tried to make it in. So how they handle that is the conflict resolution between keys and values. If there's similar ones, they're going to resolve that during the reads. And you can think about, so basically they handle the data structure as a vector. And they call them vector clocks because they obviously are related to time. So they're basically like this vector that starts going this way. They have hashes of time increments on them. And when the reads happen, they're going to, if there's conflicts, they're going to get all those vector clocks, they're going to read the time series on them, and they're going to collapse them and take probably the most recent one or the one that the algorithm figures is correct. So that's great. So that happens during the reads. Now, what are the repercussions of all of this? So let's say, back to Keith buying Indians jerseys. He's added them in there, and so the second he adds it in there, it's a put request out to Dynamo. Puts it in there. Like I said earlier, that's running synchronous, so it's coming back to the client. And there's a possibility that it's going and making its replications still after it's returned to the client. So the client could fire off a subsequent GET request, like he wants to go look at his shopping cart, and that request could go read a bunch of nodes, and the nodes that it's reading and comparing to, one or two of them may not be updated. In this sense, there's all kinds of things that can happen, but the client repercussion here would be the Cubs jerseys that he wanted to delete out of his shopping cart reappeared again. So he tried to get those out of there because they were a big mistake and a waste of money, but they came back. So Amazon said, no problem. If that's the worst case scenario, no problem. Because we'd much rather have users being like, what? I thought I deleted that. And then the delete button's right there. Boom, it's out of here. It's successful the second time, rather than like, where was the stuff I put in here? So I think I kind of agree with that a little bit if I was that user situation. So that's kind of their logic behind always writable. So we're writing to the database here. Awesome. Now that, so back to the Harambe example, Lee Page's startup company, Page Industries. So Harambe, May 28th happens, and he's getting pounded by requests. And he needs to open up another storage node. And he needs to maybe store more user profiles. He's got more memes coming in, Harambe offshoot memes, all kinds of crazy stuff. So he's going to provision a new storage node, and in the old world, you would have to take your key set and partition it yourself between new nodes or new tables and all that. So Dynamo basically takes that off your hands. They give you a mechanism called consistent hashing that basically achieves this intelligently for you. And I'll do a quick drawing of it because it's much more intuitive when you see a diagram. So in your old world here, you got your node, and sorry architects, it's not a cylinder, but you got your key set A to Z, and you got 1 million entries in there. So old world, we're adding another node. Okay, I gotta decide, I'll do keys A through L here, M through Z, however that, ends up stacking here, happens. Then, shit, we're gonna add another node. All right, now I got 3 boxes. Wait, what should I do with these keys? Okay, already it's getting annoying, because then a lot of overhead here, a lot of work. So how does Dynamo make this a little easier on you? Basically, they look at it like this. You have your key set or key space. You got 1 million on there, and they're basically taking it and creating a circle out of it. They're bending that thing into a ring. So you got Z, A. So first thing, you got your original storage node. The first thing they're going to do is create virtual nodes. And one of the key things here is in their algorithm, they keep the spacing between the nodes the same. Where they, as soon as one is added or subtracted, they're going to reconfigure the literal distance between them, so it's maximally efficient. So we have another box we want to add. It comes in. It goes in here. Second of all, there's a coordinator node kind of sitting above it that's managing everything here. So this guy, let's draw like this. This guy, new node, comes in, coordinator node. Coordinator's going to say, hey, this is where you're going on the map, on the ring. This is your key set. This guy is like, all right, word. I'm gonna walk forward to the next till I see another guy, another storage node. I'm gonna log those keys and all their values into me, and then I'm gonna turn around to the storage node behind me and be like, hey, all these keys that I got, they're all for you. They're mine now. Worry about your own. So then Dynamo's gonna take the virtual nodes, place them in a nice concentric way, and boom, there we go. He's going to say, hey, I'm up, I'm ready, and that's when those virtuals are going to get created. So now the unit of scale here is basically the partitions in between your boxes. So if we go back to like the linear graph, you basically, for every new box that comes in, we're going to create these partitions, and you have all your pieces of data in here. And that's kind of what it looks like, but they wrap it into a circle and kind of make these partitions like so. So you can look at it either way. So they're basically breaking keys into separate machines. So when requests come in, they come to the coordinator, and he tells them the best places to go. And that's kind of what brings us into the idea of being eventually consistent. And that means that every key that comes into the coordinator, he's eventually going to get it to all proper replicated nodes. So like this node is taking A through BB, right? And so if the key comes in through there, it's going to route it to there. That's the fastest node to service that request. And it's going to handle it there. So that's all from the coordinator. So as each one comes in, each key has like a preference list. So there's multiple nodes that can satisfy a request for a certain key. And so the coordinator kind of has that master list. It gets a key. It's like, hey, you can go to one of these 3 nodes. You can also configure this. It's basically, you can look at it as each key has n nodes that are the best for it. It costs money basically to have more consistent nodes, but out of the box, you do get a pretty decent consistency level. I think it's 2 or 3. So in the event of like a batch operation, or maybe a load balanced or imbalanced load balanced event, they will get smashed into here, and every node kind of has an awareness of the preference list for each key. So the coordinator can just slam a bunch of keys in there, and they will kind of route themselves. It's pretty amazing. And since everything is kind of equal distant, you'll never have like a inefficient route taken to satisfy a request. And that's kind of the idea behind eventual consistency. So data modeling, I won't spend too much time on this. It's pretty straightforward. You basically have a large table, which is like this whole thing. You got your rows, which are items, these, and then you have your attributes, which are key values. You can either have just a simple key-based table, or you can have 2 keys, which is a hash and a range. So to kind of give you an idea of what this would look like, you may have one table which is just your users, their IDs, and simple information, and then their files, like what memes they like or something, and then you would have a range key of maybe a join date for the user, and if you wanted to see like what memes did this user buy at Page Industries between this date and this date, you would run a query on that range key and it would return you user IDs. So pretty simple. So before I get into a little bit of a demo, I want to kind of talk about weighing some options in between some of the NoSQL solutions that are out there. So if you know you're going NoSQL, there's a ton of players in this market. Most of them are free. I picked 4 who I consider like pretty prominent. The one I probably know the least about is Redis, but to start with that, it's basically leverages a lot of cache. So it's very quick. It's one of the quickest solutions here, but there's a little bit of a learning curve with setting it up. There's also, once you want to add a new storage node, you're going to have to do all that partitioning and configuration yourself. And I think the data, I could be wrong, but data modeling is a little stricter in Redis. MongoDB, you hear a lot of developers kind of have this like, LOL, MongoDB, LOL attitude about it. Honestly, I think Mongo does have its use cases, and I think it's really good for those specific use cases. What's good about it, really easy to set up. You can do it in like 30 minutes, if that. If you know what you're doing, way less. You can basically set it up into production very quick as well. Why is it bad, and why do people say it can't scale? Well, it's just like one big blob, and you just keep shoving data in there, and the blob just like, just gets really big. And so there's no magic for when you're querying that big blob. So that's why it doesn't scale, and that's why it's kind of shitty. But if you're just prototyping something, if you want to have a placeholder database and you want to set up your database later because you're on a roll building your website quickly, then you should just use Mongo in the short time so you can demo state store where you need it. If you're doing a hackathon, great solution. Couchbase, I'm a big fan of it. Right off the bat, Couchbase has an entire mobile framework that is for that is perfect backend for mobile apps. It's probably the one major advantage it has over Dynamo, and other than that, they're very similar. They're pretty easy to set up. Couchbase is also open source, and it's extremely fast, another sub-millisecond. Mongo is fast too, if it's not a big-ass blob. But Couchbase has a super deep community, very good documentation, and then we have Dynamo, which I think is kind of takes all of the good things from all of these and kind of packages them together. The only knock I would say is it's definitely not touching Couchbase when it comes to mobile backend. So yeah. So what I want to demo really quick is I have like an API set up in Node where it's going to basically transition, swap out MongoDB for DynamoDB. So to kind of simulate like some of the basic steps that would need to be done and how kind of painless it is. This is all for just developing locally. So let's check that out. So some of the front-end developers just threw up in their mouth a little bit. I know I'm not using ES6. Deal with it. It's an iffy. So I'm just going to keep this right side up for now, or the whole time. That's like your starter Mongo API. So what do we got here? We got pulling in some node modules, mainly from Mongoose, and then some other things to help speed up the routing process and all that. So first you connect to Mongoose, you kind of give your data model here. And this is for, I have like kind of a tester app that I built and I use for like messing around with different node stuff. It's basically in the back end, if I would ever fill the database, it takes, it shows you a good thing and a bad thing that happened on this day in history of any time. So it takes good event, bad event, a link for it, a year, day, and a month. So that's the data model, pretty simple, just a blob of that, and then you retrieve those based on their keys for Mongo. So in here, what's worth mentioning, the get here, you know, it's pretty simple. You take your model.find, your post takes that same model, picks it off the request, saves it, and you can kind of see that it's using like a couple of different APIs to leverage some of the operations here. So how can we get this into Dynamo? Step one, let's bring in the SDK. And before you even bring in or instantiate your Dynamo operator and the document client, you have to set your config. So you can look this up online. You just get whatever region is closest to you. For this, it's local, so it doesn't really matter. And then set up your endpoint to whatever you want. And then, okay, so you instantiate these two, and all your database operations are gonna happen off of the document client. The first thing you gotta do is make a table. So with what a lot of Amazon suggests you do are create these objects, and this, you'll see this in the get and the post and delete. You create an object and then you feed that in through the document client. And that just has like all your params. So all you need to create a table is a name and your key schema. If I had a range key, that would be here under key type range, and then you specify what types, string, number, Boolean. And those read and write capacity units that I mentioned earlier, this is where you would state those. You can also configure those through the admin console. So now we want to start swapping out the actual CRUD operations. But first, this for reference, first we want to actually create the table. So we got our params here. First, you want to do a dynamo describe table. This operation is basically going to check what tables are out there. And here, you know, I'm looking for my param table name, which is up here. Is it already there? Is it active? If not, create it. And then that's just another simple operation off of the Dynamo operator. So log on, this is just for demo purposes. I'm logging the success and all that. So for an actual GET request, you're going to see this pattern again where you're basically making a params object and feeding that into the doc client. So pick your key off the request, put it into that object, and then just simply pass it in there. And then add that response, add that JSON of that data to the response. You're good to go. Post, same kind of thing. I have like, I'll show you in a second, I have a form that's tied to that URL, whose action, submit action is tied to that. And everything here is linked up accordingly, and it just puts this item in. This does not have to be consistent. I can change it up every time if I want, put whatever I want in there. and then that just gets fed in there through the a put call. So all the doc clients just basically have like put, delete, post, and all that. So if you look back here, put, post. So not much difference here. You know, it's a little, you could argue which one's a little messier. I think they're about the same. And really like swapping these out, it's really just swapping out a couple variable names. I think I have the delete on here just for reference. So yeah, it's kind of the same stuff. Instantiate your object, feed it in, and delete off of that. And you're pretty much good. Just to show that this works, for the heck of it, Lee, what's your birthday?
None of your business.
All right, we'll make one up now. So, uh-oh. So I created my table there. Sweet. Oh no, formatting. All right. So let's submit something into the database. Is anyone gonna? Steve, you want to play nice? What's your birthday?
August 22nd.
Social Security.
All right. You have a website? We'll link you up here.
Just do github.com/shabegger.
Yeah.
Yep.
And we'll make up the year from when you were born.
Thanks.
To share that. Bad. Lee Page was born today. Just few minutes after Steve, and suddenly just everything was shrouded in darkness.
Keep going.
We'll give him the Reddit Chicago link, and Lee was born in like 67. So, all right, submit. I don't have like a handler yet for this submit thing, so just trust me that it went in. You'll be able to see here, added item, successful, sweet. I gotta change a hard code value. What was your birthday? Oh, August 22nd. 22nd, yeah. So it's right there. All fully functional. So this doesn't really display, since it's not some crazy production level thing about how fast it can be, but just to show you that it works and that the transition is pretty clean, there you have it. So is there any questions or anything?
Yeah, how did you gain experience with that?
Just, so Rafe would not shut up about it, so I was like, all right, let me check this out. And then I had this like I said, I have this Node app that I've written, and when I want to try something out that's friendly with Node, I just kind of integrate it with this and go from there.
So Dynamo's open source.
I don't think so.
You can't. How do you run it local?
You just download, you make a call to the SDK and set the config, and you're good to go.
So Amazon gives you a jar that simulates how it would run in their
Oh, I'm sorry.
Okay. I was
One more
confused.
thing. When you want to actually, Amazon will give you a Java command. You put it in your, you have to actually download Dynamo to your computer. I'm running it completely locally. It might not be in one of these. I'm a bit of a tab hoarder, so deal with it. Here it goes. So this command right here starts it up locally. Whatever you port.
Make it smaller, it's almost readable.
I can't do it with this. So you'll just have to trust me. So there's just like a Java command. Once you've downloaded it, here I'll just copy it. Looks like this. Or maybe it doesn't. It's a simple Java command telling you where everything is, and then you specify your port. The port just has to match the endpoint you specified here, and then you're able to run it locally. Yeah, sorry, Ross.
Is that a truncated version, meaning you'd never use that on an actual production app? You'd always use the real AWS version, or would you conceivably run this on your own server?
Yes, you can. This is essentially baking the real thing. So once you're ready to like put it up on Amazon and point to it with wherever you're running your server, it's good to go. You would have to maybe batch upload your data to it or do something to get your data transferred, but it's pretty much the real thing. Anyone else?
You also had that list of 4 different options. Did you, by chance, compare, or is there a difference among how they handle keys and indexing?
Yeah, so there's one of the drawbacks with Couchbase is that you do, specifically, is that you do have to, when you want to add a node or something, you do got to worry about, because you'll have a metrics node, you'll have an indexing node, and you got to kind of intelligently add things to all of these, except really Mongo is just too simple for that. Dynamo, the good thing about it is that it just takes that overhead off of your hands. So that configuration, and it's really kind of a set it and forget it database other than like putting data in. So that's really the biggest plus about it in my head.
When you're running it on AWS, is there a way to like hit it just be an AJAX call instead of having to like run a whole application?
Yeah, I think that's possible. I haven't tried that, but I don't see why not.